Now we move on to the fifth topic, that is to compute integrals using direct computation and rules. This basically means we are using definite integrals. So we can directly use our calculator and solve these problems. But before that, let us just go through the basic integration formulas. These are very useful for the coming topics and most crucial in the part B section. Now we will just go through basic rules, basic formulas, which must be known. That is the power rule. If you have, say, for example, x to the power 3, always remember you need to add the power up, add the power and divide it by the added power, that is 4. And don't forget to write the constant. The thing is, integration is opposite to derivatives. So whenever we derive any constant, it becomes 0. So now if I had to derive, say, x to the power 4 divided by 4 plus 3, it would have been 4 comes down. This is derivation I'm doing, f dash, and it'll be x to the power 3 divided by 4, and this 3 becomes 0, and this cancels and you're getting x to the power 3. So this is derivation of the answer, you get x to the power 3. When you integrate, you won't get that because we cannot integrate. But so that's why we write c, because look over here, the 3 is dissolved to 0. We do not know exactly which constant. Even if I add instead of 3, say 10, it would be 0. So the c means any constant number. It can be any number. So that is the thing. So these are inverse of each other. When you integrate something, you will get the answer, and when you derive, sorry, I'll tell it again. When you derive one thing, whatever the answer you get, when you integrate that answer, you should get the derivative of the question. It's basically inverse of each other. That's about power rule, and that's about c as well, the constant. And now few of the basic formulas, 1 by x dx. See, it's like opposite to what is derivative. If you have remembered the derivative formulas, then these integral formulas will be easy because they are similar to it. 1 by x dx is natural logarithm magnitude of x plus c. Now sine, cos, secant, and tan, and cosecant square, and cosecant and cot, they are similar to the derivatives, but there is few things you must remember. Whenever you integrate something and the answer is starting with it can be cosine, cotangent, or cosecant, you must add a negative sign. If it is sine or tangent or secant, it's fine, just write it as it is, no need of the negative sign. Whichever has will have, or whichever has c will have a negative sign over here. And then there are a few more formulas about exponential, that is as it is, but if it's minus, remember to add the minus sign down from chain rule. And then we have over here the inverse trigonometric function formulas. These are also very important. You need to remember this. Whenever there is no square root, it's just 1 plus x squared, it's tan inverse, whereas sine inverse has square root and it's 1 minus x squared. Whereas if it's secant, then you have magnitude x times x square comes first minus 1. Now let's look into the problem. There are only two problems in this topic 5, and they are very, very easy because all you need to do is definite integrals. So you need to just put this and write the problems as it is, square root x alpha x minus 3, and write the limits appropriately. It starts with 3 and goes up till 4, and press equal to sign. It might take some time, but it will definitely give you answer after a few seconds. The answer is 2.4. And you can use the formulas and solve for the same answer. Here you're getting 12 by 5. Don't worry, because 12 by 5 is the same thing. If you divide 12 by 5, you're going to get 2.4. So sometimes you may not get, your answers will be in decimal generally. You may not get the fraction, or say in terms of pi, you may not get the answers. So look into the 4 options, because this topic 5, you will have 4 options. Solve them and compare to the decimal form. Same way over here, just use the definite integral symbol and type the values. X times x minus 3, the whole square, and the definite integral starts from 0 to 1 plus equal to, and the answer is 11 by 4. Here it's in fraction form. So this is how you can easily solve definite integral problems. In the next video, we will solve the sixth topic.